the good old days when you were watching TechWiki with nothing but a television antenna. I mean, not really, that never happened, but you know what I mean. Your TV was able to pick up a signal that just kind of emanated from a station somewhere that broadcasted the signal in a big kind of like bubble that anyone in range with a TV and bunny ears could watch. But of course, videos on YouTube and other sites don't work this way. Instead, internet traffic actually has to be routed to the correct place directly. And unlike an old school TV or radio signal, online data has to know where it's going. So how then does it do this? Well, this is where something called TCP/IP comes in, which stands for Transmission Control Protocol and Internet Protocol. Now, you may have seen some vague references to TCP/IP in your network card or browser settings, but what exactly is that? You can actually think of TCP/IP as a cake or a club sandwich, since the way it works is often conceptualized in layers. It's just that those layers are made up of computer code instead of icing or delicious corned beef. The topmost layer is called the application layer, which is what programs like your web browser directly interact with. This layer has protocols like HTTP if you're visiting websites or SMTP if you're checking your email. The next layer down is called the transport layer, where TCP lives, along with another scheme called UDP, which is a bit faster and useful for low latency applications like online games. After the application layer gets the data from whatever program you're using, it talks to the transport layer through something called a port. Now, each port can be assigned to a different protocol in the application layer so that TCP knows where the data is coming from. For example, most activity in your web browser will go through port 80, which is what HTTP always uses. Once TCP gets the data, it chops it up into small chunks called packets so that they can be disposed of in a nearby lake so no one will ever find, no, sorry, what were we talking about? Where they can individually take the quickest route over the internet to get wherever it is they're going. To make sure that the receiving computer can put the packets back together properly, dental records are included. To put it back together properly into driving directions, a TechWiki episode, or an advice animal meme, TCP slaps a header onto each packet that contains instructions on what order to reassemble the packets into, as well as error checking information so that the receiving computer knows whether the packet's data arrived without any mishaps. After this is done, the packets are pushed onto the creatively named Internet layer, which uses the Internet Protocol, or IP, to attach both the origin and destination IP addresses so the packet knows where it came from and where it's going. The data is then sent through the final network layer that handles things like MAC addressing, so the packets go to the right physical machine, as well as converting the data into electrical impulses that will actually pass through the proverbial series of tubes. And although every single packet of data has to go through all of these layers, packet switching actually makes the internet faster than it would otherwise be, since it allows each packet to individually avoid congestion and bottlenecks that would occur if all the data had to travel along the same route during each session. TCP/IP also streamlines things further because it can deal with packets from all your computer's applications so that your browser or game doesn't have to do that by itself. So all this stuff going on behind the scenes means that you're usually not kept waiting for too long. At least not anymore, since TCP/IP didn't exactly save us from blocky videos back when we were all using phone modems that sounded like a couple of droids trying to have a conversation. Wouldn't that be funny, like a sci-fi movie set 30 years from the future where instead of the droids being like beep boop 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 boop, they actually sound like modems?
That's what modems are doing.
I know that's what they're doing. Damn it, Taryn. Speaking of what modems are doing, they are telling the sites that you visit where you're visiting them from, and TunnelBear VPN lets you hide that data. So it allows you to tunnel through up to 20 different countries, allowing you to browse the internet and use online services as though you are in a different country, effectively making it so the websites and services that you visit don't know what your destination IP was. It instead gets replaced as soon as you turn on that TunnelBear switch with an IP somewhere else in the world, wherever you select, in fact. They've got easy-to-use apps for iOS, Android, PC, and Mac, as well as a Chrome extension, and all you've got to do is just pick a country and hit the switch. Your connection will get encrypted, and your public IP will be switched, and you don't have to deal with any of that nonsense like configuring ports or DNS or blah, 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 blah. It's simple enough that my mom could do it. They also have a top-rated privacy policy, and they do not log user activity. The best part is you can try out TunnelBear for free with no credit card required with 500 megs of data at the link in the video description, and then you can save 10% when you decide to sign up for an unlimited data plan by heading over to our link, tunnelbear.com/Linus. Speaking of Terrence complaining, guys, like the video if you liked it, dislike it if you disliked it, check out our other channels like Channel Superfun over here, comment with a video suggestion below, and don't forget to subscribe and follow and all of that good stuff. See you next time.
Hey guys, this is DG. Today we are going to learn about OSI model or Open System Interconnection Model. So let's start. OSI model defines and is used to understand how data is transferred from one computer to another in a computer network. In the most basic form, two computers connected to each other with LAN cable and connectors sharing data with the help of network interface cards forms a network. But if one computer is based on Microsoft Windows and the other one has Mac OS installed, then how these two computers are going to communicate with each other? In order to accomplish successful communication between computers or networks of different architectures, 7-layered OSI model or Open System Interconnection Model was introduced by International Organization for Standardization in 1984.